helping researchers work to end world hunger. Image, ViGIR Lab, University of Missouri at Columbia. At a time when many people are concerned about the potentially negative impact of robotics on individuals' lives and livelihoods, researchers at the University of Missouri are relying on robots for a project that's decidedly pro-human, fighting world hunger. Robots are helping scientists track crops and how they grow in drought situations. Knowledge gained from the 3D images and data the robots create and collect could help agriculturists develop corn that is more drought-resistant. Also, robots and drones, coming soon to a construction site near you. Robotics in business, everything humans need to know. An executive guide to the technology and market drivers behind the $135 billion robotics market. Read more. To develop 3D images of corn plants in the field, the research team developed a combination approach of a mobile sensor tower and autonomous robot vehicles equipped with 3 levels of sensors and an additional robotic arm. The tower inspects a 60-foot radius of a given field to identify areas affected by environmental stresses, while the vehicle collects data on individual plants. The sensors have the ability to measure various heights of the corn plant in order to reconstruct the 3D image. Measurements taken from the tower alert researchers if plants are under stress such as heat or drought, and the tower then signals the mobile robot to go to a particular area of the field and collect data on individual plants. The robots can collect data on temperature, humidity, and light intensity at 3 different levels on the corn plant. This is referred to as plant phenotyping, which assesses growth, development, yield, and other characteristics. We develop robots that can extract phenotypes of plants in the field and correlate those traits against plant behavior, resistance to abiotic stresses, and ultimately to yielding, said Guy D'Souza, an associate professor of electrical engineering and computer science at the university and head of the research team. Computer vision plays an important role in the technology. Without cameras and all the algorithms that we develop for 3D imaging, feature extraction, navigation, etc., it would not be possible to do what we do with these robots, D'Souza said. Developing drought-tolerant corn that makes efficient use of available water will be vital for sustaining the estimated 9 billion global population by 2050, according to the researchers. The group includes colleagues and students in D'Souza's vision-guided and intelligent robotics, ViGIR, laboratory, as well as other researchers at the university. The research effort began in 2012, and in 2014 the National Science Foundation, NSF, awarded the university a $20 million grant as part of a multi-institutional consortium to study climate change and how corn maintains plant growth during drought conditions. Using funding from NSF, university engineers on a multidisciplinary team developed the robotic system that they say is changing the way scientists study climate variability, crops, and plant composition. There is still a lot to be done, especially in the plant science side, D'Souza said. That is, studying the correlations provided by the data, and determining the families and the genotypes that will indeed help plants, such as corn and soybean, to adapt to those abiotic stresses. But the project retains its ambitious goal of helping to end world hunger. Hopefully, robots and precision agriculture in general will help, D'Souza said. Previous and related coverage: robots in the cloud, how robotics as a service can help your business. Companies are now offering robotics as a service to help customers with management tasks. How do you turn these islands into a living AI lab? Just add 500,000 sensors. The TV and radio masts already exist, so adding AI antennas is a logical step for Spain's Balearic Islands. Optimizing organ donation. When big data and analytics helps save lives, this organ-sharing network relies on technology platform to speed up vital report generation.